Hello students, welcome to today's session of Daily Chemistry Dose. Today we shall be discussing one important question based on the topic of tautomerism. So this particular, I would consider this as to be wow problem. Wherever I find something very good question, I used to say it as wow to my students. So this you would also consider after this session that this particular problem have given you a good amount of insight into the topic of tautomerism. Now, as regard to the tautomerism, the seeing the length and breadth of this particular topic, it is a very lengthy one. But what one question I'm going to consider in this particular session, keeping myself into that particular region only, I shall be explaining few things before I actually would pass you one question on based on this. Let me give you a little insight only for 2-3 minutes that what exactly and how simply you can understand tautomerism. First of all, you have to have a function group which would have a multiple bond. A function group when it is having a multiple bond and such that if, say for example, this is the function group which I have taken xy, and if y is more electronegative than x, so there is a sort of this sort of a moiety is there. If you have this sort of moiety with you and it is being attached with a carbon which we consider as to be alpha carbon because it is directly attached to this function group which is having a multiple bond, with polarity. Now what would happen, we tend to say it that way, that if I would place it once again like this, that if I have this sort of a situation where x is more negative, y is more negative than x, what would happen is this two electrons would come here and this would go this side. Why? What is the driving force? The driving force is this y negative would abstract this h positive. As a consequence, what you would get here is something like this x, and here comes the single bond with y, and this is h. This is the best way to learn the topic of tautomerism. I am not saying that it is only the alpha hydrogen which can do this sort of a thing, but most of the time to begin with, you always have to see this. If you have a alpha carbon of the type sp3, then this hydrogen can move. This hydrogen, in fact, in my physical classes I used to say, is very notorious. This hydrogen always want to go to a more electronegative element, and in the process what you happen to get is a dynamic equilibrium between these two. Now if I would apply this into some of the moieties, just I have placed it to save the time. So if this, you can see this is a multiple bond which is slight negative, this is slight positive. If you take these two electrons here and will bring it here, so what actually you would end up getting here? So you would get something like this. This is the best way to learn the tautomerism in a speedy way. So we call this as to be keto group or aldehyde group, but this what you have generated is a double bond enol. So we tend to say it as ketoenol tautomerism. Similarly, now if you could see in this particular case, this is delta positive, this is delta negative, and this H would want to go to the nitrogen which is more electronegative. So if you would go a little philosophically, that inside this molecules lot of things are happening which we generally don't feel it that way. So that is very interesting to tell you. Now what you would end up here is with this type of a species. So now this is what you call it as cyno, and this is ene, and this is imine. So a sort of enamine type of a species is being formed, and here also you could see this carbon, one bond is missing. This is delta positive, this is delta negative, and if I bring it here and this here, such that this sort of thing is being generated, double bond here, and here you would get NH2. So I should place a carbon here and you would end up getting this. So this is what you call it as enamine. This is enamine type of a species is being formed, and this is nothing but imine. So what basically I'm doing is that I'm just picking up those species where you have a XY has a multiple bond and you have a alpha hydrogen which can migrate like this, and as a consequence you would end up getting a new species which would have this sort of a entity. Now what basically it is nitroso, and this is a sort of what you would call it as to be oxime. So this is the oxime formation, and similarly here also this is nitro, and this moves here, and you end up getting something like this. This is called as a very popular one. This is called as nitro SE tautomerism. This is a common name of this function group as SE. So in a simple viewpoint, we just have able to understand that wherever you have this sort of a thing where you have a moiety like XY, that if you, I just once again would write that you have a alpha hydrogen, but alpha, at the end of the session I will explain that even though if you don't have alpha hydrogen, then some other part of the molecule could also tautomerize this way. So what you have to figure it out, that you should have this sort of a multiple bond, and then this can be brought like this. So now coming on to the question, let us go into the details of the question. Beautiful question. Try this out by pausing this video, and thereafter I will do it. So I hope you people have tried this question by pausing this video. Now this is a very interesting question, that there is a phenol or phenolic part is there which is being treated with a compound which we call it as hydroxylamine. This is what you call it as hydroxylamine, and those who have already done aldehydes and ketones might be knowing that hydroxylamine could react, it is ammonia derivative which can react with aldehydes and ketones, but in the starting material I am not seeing any sort of what you call it as any aldehyde or ketone. All of these are phenolic group. Here I just have forgot to tell you that all of these exist in equilibrium. That's a different question. That is why I am saying that the length and breadth of this particular topic is very lengthy, that what are the ways and means by which you can shift an equilibrium towards enol or towards keto or vice versa. What are the conditions, that is very important, but they exist in equilibrium. Now see here what we shall be taking up in this particular question. So first I will do it because this is being given to you. The starting material is given to you like this. This is basically enol. And if I would do a tautomerism here of the type, now if I could do this way, this is very interesting to tell you, very interesting. So if I bring it here, this here, so what I shall be getting something like this. This becomes double bond O, and this H came here, which actually tautomerized because this is alpha hydrogen which tautomerized to give you this particular moiety. So if it would happen from all the sides like this, if it happens from all the side, you would end up getting this result. Now what exactly it is we got, this is basically enol. If I just figure it out, this part, this was enol, and I changed this enol into the keto form, and the equilibrium is generally this way driven because enol, because here in this enol there is aromaticity. So aromatic enol would be more stable as compared to the keto. But if the aromaticity is not there or some stabilization factor is not there, then ketone is generally more stable. Now the matter of the fact is, if I just take the enol as a starting material, it would not react with that particular reagent. So what would happen is, we shall be saying once this enol, or let's say this percentage of this is very less, the keto form, because it is not having aromatic character, but once it is being formed, it can react with what you call it as this compound. Let me rub it from here. This can react with this moiety. Which moiety? Hydroxylamine. Now for that, let me first show you how does it react. So this is a very popular reaction, that keto treated with hydroxylamine. This also would engage a mechanism, but here I just be telling you the shortcut. So this water goes out. This is nucleophilic addition with loss of water molecule, and you end up getting hydroxylamine. So this again is a very important mechanistic viewpoint is there, but here we shall not be taking up that in very much detail. So I shall be making one video on that part also. So this water goes out. Similarly, it can be removed from this direction also, and this can also be removed from this side also. So the water goes out, nucleophilic addition followed by, so if I hurriedly would give you a bit of idea, this is nucleophilic addition and followed by dehydration. That is what the basic viewpoint here is. So what you end up getting here is a beautiful compound of the type this way. So this is what you achieved. So you achieved this compound, beautiful. You achieved what you call it as oxime. You got this as oxime. So do we see something given in this? Yes, I could see this option. This option is there. This option is there. Let me check whether this can go further somewhere. Now let us see what exactly it can do now. Now you have generated a hydroxylamine. Now this is very beautiful. You have generated a hydroxylamine, but I may do the reverse way which I started with, that if I bring this hydrogen here, this proton here, this would get a negative charge. As a consequence, concentrate on the thing which I am just making. I would be getting something like this. Here you have a double bond O. This H has gone out as H positive. This has lost out as H positive because these two electron came here and these two electron here. So this would carry a negative charge. So here comes the H. And similarly, you can do the same thing from this side also. And you can also do the same thing from this side also. Wow, beautiful. So this basically is nitroso, which we have just few minutes back have written nitroso oxime tautomerism. Nitroso oxime tautomerism. So I just have generated nitroso. So let us check, is nitroso there? Yes, it also is there. Now, once you got to know that, because the products is being asked, it is not asking anything about the major quantity. The product is being asked. So, if A and B are there, C would definitely be there, because then the answer would be all of these. Now, let me check whether we can convert this further somewhere. Now, this is very beautiful. So, the thing is that if I consider this molecule once again, this particular molecule once again, now what I shall be getting is that if I place it once again like this, I just have wrote the oxime. Now I may also think of this way also. Just hold on for a minute. I just would want to draw it. So if I place it like this, now see here. Now if I consider this as to be happening this way, that if I place this hydrogen, if I take out this hydrogen and bring it here and take this here, now concentrate on the thing which I am just making it. So what I would achieve here would be a double bond here, and here comes the nitrogen which is attached with OH, because since this nitrogen is getting a lone pair from this side or the negative charge from this side and H positive joins it, so this gets this one, so this becomes a hydroxylamine. So similarly, that sort of a thing could happen from this side also, that you can bring it here, this goes here, and you can also do it from this side also. Now this is very interesting to tell you that you now would achieve what you call it as hydroxylamine. So this also could be a case. So all of these are happening in equilibrium. Although this achieved the aromatic character, this achieved the aromaticity, so this would be a major quantity. But in the question, it has been asked that what can be the products. The products of this reaction now could be written as this also is a product. One product is this, another product is this can also be formed because all of these are happening in equilibrium, and along with this you would also get this also as a product, which we have already written. In fact, this also is a product. So we shall be saying that the answer to this question should be D option, that all of these would be produced. Now if in case one of the other option is also given, which also is formed during the reaction, say for example, if in case they have given D option as this one, if they would have said you that is this, which out of these, now if this D option is also there, A B C D, then you have to check which among this is the best answer. They have given you a you have to identify one product of this reaction, then we would have gone for the C option because it has achieved the aromaticity. Now another thing which you should also focus on in this particular topic of aromaticity, generally it is so it is students start feeling that it is only the alpha hydrogen. No. Now if in case you have this sort of a species available for you, now say for example this is what you call it as, now somebody would ask you, will this compound tautomerizes, is it possible for it will this compound tautomerizes? So this also is a very important question. Here you have a alpha, this is alpha, and this hydrogen is beta, and I may say this hydrogen has to be gamma. So which of these hydrogen is enolizable? So here you just have to figure it out, that if I just would place this hydrogen out of here, or if I deprotonate it from here and bring this bond here and this here and this here, wow, so this would tautomerize like this. So this also is a very interesting viewpoint, that it is not, you need not to fix it yourself to that particular thing, that it is the only alpha hydrogen which is going to undergo tautomerism. It can be some other hydrogen, but only thing is that if in after tautomerism it provides it a stability, the equilibrium would shift towards that side. So this is what you would say, this is again aromatic in case. Now another thing which you should think of, that if I remove this one, if I remove this one, what would be the case? Then you would have this sort of a scene, that this sort of a structure is being produced, and this is highly unstable because this carbon has become sp, and to get the linearity, this bond would break. So this hydrogen of this type, which is sp2, would never undergo tautomerism. So this is again, I am saying it is one, again and again I'm saying the same statement, that the length and breadth of this particular topic is very lengthy. I tried my level best to keep myself to this particular question only, whatever are the things are required. So this is a beautiful question, I liked it very much, and hope you also have enjoyed this particular question. So keep seeing my videos, and if you have not yet subscribed to my channel, do subscribe and share it with your friends, that someone somewhere would be going to get assistance or help from my videos. Thanks a lot, have a nice day, stay safe and take good care of yourself. Bye bye, and lastly, happy Visakhi to all of you.